Hey there, this is Lester Martin, and I'm going to spend some time running through a framework called PyStarburst. Really just giving some examples of using this data frame based environment. Should look a lot like, if you're familiar with something like PySpark, then very, very similar. This will be an easy video just kind of comparing and contrasting. And if you're new to concepts like Spark or even the data frames APIs that are out there, for now, except that I'm not going to go into super detail and explain that whole data frame concept, but think of it as a collection of objects. Think about maybe reading a table or a file, and all those records together make a collection, and that collection is a data frame. A whole lot more to it about lazy execution and all this, but not stuff we want to get into today. So I'll put in the comments this URL, but there's a GitHub project under the Starburst data account here called PyStarburst examples. That's what I have pulled up. And this is really, today at least, March 2024, not a really big project. It's got some examples. I'm going to focus on some web-based notebooks, some Jupyter notebooks. And I drilled in here, and actually the one I'm going to show you today isn't quite in here. I have a pull request waiting to bring it over, a whole new notebook, as you kind of see here. I'll describe a little bit more there, but I'll kind of go into it and show you. But really, if I go back to the home page, what I want to say is what's nice about this GitHub project is the creators over here on the right from Starburst, where I work at, did a nice job of just saying, hey, you want to run some of these? Hit this nice button called Launch Binder. So I'm going to click on that, and what you should see is I'll spin up here, just give it a few seconds, and we'll end up running an instance of Jupyter that we'll be bound to and linked to and all that kind of good stuff. I'm not going to go into the great details of Binder and all this kind of stuff. Really want to focus on the code. And once you get this pulled up, what you would do is just double click on the left under Notebooks. And here we're actually only showing two notebooks. The one I'm going to demo on this video will be here shortly, but it's not, the pull request hasn't been fully accepted yet. So what I'm going to do is, at this point, I'm going to minimize that, and I'm going to switch to my local environment. So I actually have the same, it's called TPC-H. That's what should show up in that list as a third. And like I said, maybe in the future, maybe there'll be more than three example notebooks out there. But this is the one we'll focus on. So let me stretch it out and give us the whole screen to work with. And what it says here is to play with this, to exercise this, first and foremost, you need to have an instance of Starburst Galaxy. Good news there, that's free stuff to go sign up and everything. Technically, this should work with any Starburst Enterprise solution as well, but I'm just trying to keep it simple. And the data set I'm going to be using will be readily available in this. We'll be using a connector called TPC-H. So once you get all set up with Starburst Galaxy, you want to make sure we have, there we go, this connector, this catalog, TPC-H. You can read more about it, links here about where this comes from, but it's really a small little system with about 8 or 9 or less than 10 tables in there, and I'll show you those in just a minute. And you can verify that's all there by simply pulling up your Starburst Galaxy or other Trino or Starburst environment and making sure that, let me log in here, making sure that you can see that particular catalog in the cluster that we're running. So I'm going to use, in Galaxy, I'm going to use the free cluster. That's the one they set up. It doesn't cost anything. It's my favorite. And if you look under here, under free cluster, there it is, TPC-H. So there's multiple schemas within that catalog. They're all really the same of what's in there. I'm going to be focusing on the tiny one. So customers, line items, orders, regions, suppliers, all that kind of good stuff. That's the data set or schema full of data tables that we'll be accessing. All right, let me get back to the notebook and see what else we want to do. Oh, lastly, I said, why don't you pull up the data frame API, the PyStarburst data frame API documentation here. Now, I'm not going to dive into this. What I did do is, as I was going through the notebook, I referenced that. I'll give you an example. Here we go. When we start doing something, I'll put links to specific classes or functions or methods or whatever, functions or methods as I'm using them. All right, let's assume you're up. You got your Starburst Galaxy running. You got the TPC-H catalog and everything. Definitely what you'll need to do, and I'll go ahead and run this one, is run a pip install. So you need pip, Now the good news is this is the notebook that will be up from that launcher. And that environment has everything you need. So do click run on this. So mine's pretty short. Yours will take a little longer because it's actually on that container actually installing this. Mine's all current and everything, so that's fine. So install the library, and that'd be a one-time if this was your own notebook system like Jupyter or Zeppelin or whatever you do. What else can we do? Well, we definitely need to connect to our running cluster. So here I'm going to ask for a few things like host name, usernames, and ports, and that's pretty easy to find over here in Starburst Galaxy. It's just down here at the bottom. I'll just do a little copy and paste. So there is my host name, and my username is right there. Easy breezy. And my password is something I know. Bad news is it won't tell you right then if it passed. You'll find out in the subsequent notes here, etc. paragraphs. So I'm going to kick this next one off. Now this one actually is doing quite a few things, right? It's connecting, it's got import statements and everything. It's using those credentials that are provided, and ultimately it's creating a session. This is a lot like, for you PySpark folks, the session object, Spark session that you're thinking about. And then just a quick validation that we can actually touch the server, the cluster, and get something back. So I wrote a bogus select one as B kind of thing, and in fact what I can do is verify. I know it ran because it would have failed, but I could definitely come over here and look at my query history, and there it was, select one as B, etc. So I see in my query history on my Starburst Galaxy ergo Trino environment that I am running that one. All right, so let's do a little bit more interesting things beyond that. And I gave you a link again to things like session SQL, what you can do with that. What else can we do? Well, in addition to the .SQL method, which lets us supply any SQL, so we'll run a simple one, right? Show tables from the catalog TPC title. There we go, tables, customers, line items. These are the things we saw earlier, but really what it is an intro to the .SQL method on session. This is our opportunity just to type things that we would normally type, in our query browser, our query editor, whichever one it is, not just the Starburst web UI I'm using, but dbeaver or your BI tools or whatever. All right, we did that just because I want to show you there's a few tables, reference the ones I already showed you. But if I look a little deeper, I'll go ahead and kick this off while we're talking. I actually have a quick statement. It said, hey, session object, do a table. Now table says, give me a table name. And what will I do? I'll return the entire contents of that table into a data frame, a collection of rows, and that'll be called TLI. That's just whatever variable that I assigned is. Tiny line items, TLI. There we go. And then what I did is I said, hey, data frames themselves, right up here from the .schema, have a mechanism to say, show me what that looks like. Now, that's a kind of ugly one. So what I did do separately is right below that, I said, hey, with that same TLI, just do a for loop and do a little bit better job of printing out, what it's called, the field name and data types, etc. Now for my PySpark experts, there's one called print schema, and that's something that I would imagine will show up here, or maybe a simple commit and a pull request that it's on my list to try to do. But nonetheless, here is the schema of that world. Now, once we have a data frame, what we really can do is lots of transformations and whatnot. We can do things with it, and that's what I'll focus on. And I mentioned code words like lazy execution and kind of stuff. Basically, what's happening is the engine's waiting for what we call an action. We're waiting for a write or a display or a count or something like that to really, really do some work. So I click this button here, show, and show says just dump whatever is in that data frame. So let's go look in the query history, refresh the results over here, and see what really, really happened. What really, really happened is this. We ran a select all from TPC tiny, And it actually inserted a limit of 10. It even did offsets. It just built in is like the best, most elaborate query it can based on what we just did. But really what's happening is this. The show command is, like I said, an output. But the show command without an argument will only display 10 rows anyway. So that command injected a limit 10. If we wanted to see more than 10, put 100, 1,000. If you want to see them all, put a really big number that's bigger than you would expect it to be. So show does what? Explains what's going on there. Shows it, dumps at the screen. Now, Jupyter doesn't do my favorite. It actually kind of wraps everything. It looks kind of ugly there. So why don't we take that as an opportunity to talk about a few other things. Just shortly, quickly, I would say that once you have a data frame, so TLI is a data frame, you may run other operations. So that's what the docs show us. There's lots of operations, are often referred to as transformations, that say take that data frame, do a function on it, so run at scale, run in a highly parallel fashion, and create another data frame. So we don't edit an existing data frame, we do something to it, and let's just say elaborately a very parallelized version of a for loop, run through it top to bottom, and build yet another one. So there is one function that I'll introduce real quickly, an easy one. It's called select. And select just simply says, okay, of the fields that are in TLI, only show me, and here we go, order, key, line item, etc. And I'll run that just to make the point. So what I did is I have a new one, TLI projected, and TLI projected has those 5 columns as you see there. So we got TLI, we got TLI projected, and in fact, every function that we run on a data frame either creates another data frame or does some kind of action on that data frame. So some kind of physical I/O, write it, display it, something along those lines. And, we could probably go back and look, well, not probably, we can go back and look at our query history and refresh those results. And guess what we see? We see a command, select those 5 fields. Interesting enough, the way it's done is from selected this and everything, and you can have a lot of fun with this and drill into things like the query plan to make sure, while it was written a little interesting, did it do exactly what we're thinking, etc. It sure did. Nothing all that magical or whatever. We're still waiting for the optimizer to do this. And really, maybe what I haven't said clearly is this engine is different than something like PyStarburst, which is ultimately going to submit the work into a Spark cluster of some sort, hosted on CDP or Naked or with Databricks. Here, we're ultimately, when those actions occur, what we're doing is we're building appropriate SQL and then submitting that SQL to the underlying Trino engine, the Starburst Galaxy engine, getting the results back, putting that into something. If it's a visualization, if it's a write, we'll just get, okay, I wrote it, or if it's a number, like how many rows, we'll get a number. But if it's something like this, some kind of display, we'll bring it back and then we'll output it on the screen. Now we could just add a simple sort to that, and simple sort, I mean just maybe one of the columns above, and kind of like an order by you see in a SQL statement. What we can do is on a data frame, such as this, tiny line item projected that we just created above here, we can simply say sort it by the column called order key. Let's see what that happened. And there are those results as you expected. We sorted it by the order key 1, 2, 3, 4. Now we could have gone a little bit further on this particular one and just add maybe another column, because order key and then line number would make the output look a little bit more realistic. And again, I have a couple things to kind of go at and say over and over. One, we're waiting for these actions like show or write or something to do work. So this did some work, and we can definitely go over here and look at our query history and find the work that was submitted to the cluster and then run to ground. There's our select, order by this. And it might look a little bit weird the way it was implemented. This is because what's being sent over is what looks like from the data frame. The good news is, again, like anything else, if you go to the query plan, you're going to see a very positive output. You're expecting the cost-based optimizer to figure out what you want to do and do it the most efficient way. Other things that it might be worth mentioning is you see that I'm reusing this TLI projected. Again, it's not time to go into a deeper understanding really of data frames, but they're not really fully implemented. They're like instructions of what would be there. So we don't have this. Every time I run this second one from this first one, it has to kind of go back and submit a full query to do that. That's just how these big data frame concepts work. Something to consider. So we can reuse them easily enough, or we don't even have to name them like you see myself doing in most of these examples. We could chain a lot of methods together, and you'll see that as we continue on. All right, so here we go. I'm going to run another one while we think about it. So we did some simple sorting. Why don't we do some simple filtering or where clauses or predicates? And generally speaking, we'll use our filter command. And like you see here, filter command, just give it a little bit of domain-specific language, so a little bit of SQL that says, hey, look, I'm looking for the order key under 5. Now, a couple other things. We also, as I just mentioned, chained another method. So TLI PFS is, let me say it this way, this projected data frame is running a filter. The filter creates a data frame. That data frame and then runs the sort. And as I was trying to say a minute ago, these chains don't necessarily mean that we're going to go read, a billion rows and then work on and then filter those billion rows and then sort those billion rows. They are in a comprehensive set of instructions. And then when we trigger this action like show, it'll actually run that and see what happened there. And we can see that again right there in the query history. Let me make sure I got the latest grade to see it. There we go. There's our query, right? Read all this, sort it, do it. Just one big quick operation, as you might expect. All right. So chaining those together is not a bad thing. It's a good thing. If I didn't mention already, the show command actually is only going to return 10 by default unless we provide it with some names. So again, I'll just change this for fun and say show 50. And see if we can run it again and get a few more of the order key, less than equal to 5. There we go. That's less than 50. That's the whole 1, 2, 3, 4, 5 that we saw. So we set that back for that example. All right. What else can we look at? Well, if we really just want to have a simple answer, like how many things are in there? This TLI PF, this projected and filtered and sorted tiny line items. How many are there? We just kind of showed above that it's more than 10, but how many is it? We probably saw about 15 or 20. Let's see what it actually says. 17. There we go. It's pretty good. Quick guess based on glancing that. And that also is one of those actions I'm talking about. So we're still calling on a data frame. It gives us some output. It forced something to run. I can keep going back each time and looking at the query editor, the query history, and I encourage you to do that as well. What else can we do? Well, I'm going to make the point that the show is an output and the show is limiting, but it doesn't necessarily mean that the data frame, conceptual at least, is limited to 10. It just means the output will see that. Example, if you really, really wanted to limit something, is what you see there. Use a limit command. Now, limit command is going to look like a limit clause on a SQL statement itself anyway. So select whatever, limit 5 in that case. So absolutely do that. And, I did it right here anyway. It was more than 10. There we go. So it had, I think, 17. There's those 17. I guess I already did that. Didn't have to show you above. I was going to get to it here below. Now, a thing to really consider is while this API is fun, as a programmer especially, doing things like this are more interesting and more challenging and more fun for some of us than others. Just not that it's right or wrong, just some of us like to do that more than others. But some people might argue that, hey, couldn't I just write a SQL statement. Sure, use that session object that you created with your credentials, fire off the SQL method. We saw a really simple example earlier, but here's a little bit, still simple example, but a full query, right? Select these things, where clause, order by. In fact, this is the exact same SQL that would give us the same answer that we saw above. So we should see the same kind of 17 rows right here, show up right here, absolutely. And sometimes this is just a matter of preference. I'll go ahead and make the point that you can actually do some mixing and matching of the SQL and the API. Now, this generally speaking would be like start with SQL and then the data frame that it gave you add more opportunities. So how about we do part of the query, just do the projection, and then maybe do the filtering, the predicates, and the sorting, ordering from additional method calls. Will this give us the same answer? It sure will. And arguably, this, and this, all three of these approaches, because of the cost-based optimizer, regardless of what the Python piece sends to the engine, that they should come back, they should be implemented. They should at runtime have a query plan that looks identical, if not highly similar, but identical, and have the same kind of performance and those things. Now, what I did do right here, just to verify at least that the work, the output, the results were the same, I said, let's compare that PFS. Again, the PFS, I'll scroll up a little bit, was right here. This was the projected, filtered, and sorted version. This is that 17 rows of everything under order key of 5. And the other one was this one, same name with SQL. This was the SQL's generated one's data frame. So I use a function called accept that just says, hey, what's in this one that's not in that one? And, it's empty. That's good. They're the same. They're exactly the same. So showing you that the functionality is the same. To a little bit more, go back to the Starburst Galaxy, walk through the history, look at the different plans, and verify they're the same. I'll let you do that on your time, people, though. All right. What else can we do? Well, again, we're just trying to run through a bit of the API for some familiarization. This just makes the point that we saw that if you had a data frame with a lot of columns in it, what could you do? You could say, hey, I only want a few of those. So if you had 100 columns, you only want 5, then you'd probably say, hey, that data frame dot select, and then pass it those 5 column names. If you want to go the other direction, I've got 100 columns, I want to get rid of a few, 3 here or 5 or 10, do the other one, do the drop side of that. So, hey, take that data frame and drop some number of columns. Now, as you see here, it's kind of busy on my screen, so I went ahead and said, I guess I didn't. I thought I dropped a few less, but at some point, if I dropped too many, then the select would have been smarter. But okay, select or drop, or just simply saying, take the data frame and then give me either, I want a subset, but which way am I going? Remove from, or only, give me just certain ones. What else could we do? Could we run a bunch of predicates? Sure. And like I said earlier, just filter. Take a function, take a data frame, run a function, that returns a data frame, dot, run another function, dot, run another function, dot. And don't think this is going to build, and I'll go show you, that's not going to build multiple passes. It's not going to loop through the tiny light items to do one filter, then loop through it again to another filter. It's going to build under the covers a pipeline of operations and do that all in one stage and so on and so forth. And if we go look, and then there's our projection, let's just go look at that one and make sure we agree that it's not going to scan through those results over and over and over. All right, so I'm going to refresh this. Look at the latest query. I think I refreshed, yeah. And see if this is our latest query. So select a few fields. And again, this is just because the PyStarburst is walking the code the way you implemented it, it's expressing it in something that looks like it would do exactly what I said it won't do. Read this and then read it again, then read it again. Let's go verify by looking at the advanced page and pulling up our, here we go. Here's a perfect example. We're going to do one scan, filter, project on our line items. And then we're going to do all the other fun stuff while I'm at it, but I'm only going to scan that one time. And in fact, all we're doing here after that is send to another stage. It's our kind of reporter back or handing back to the client. This is pretty typical in the way Trino works. They call that a single instance stage, and its sole mission is to hand the results directly back to the client, the calling client. And for those that have played around and know about this, you could also look at the graph and you can say, good, I don't see that we're doing a whole bunch of stages to loop through, and loop through. So absolutely, that'd be bad if we did that. All right, let's look back at the TPC. All right, so filtering is a pretty normal concept. When do you, chain these methods is a pretty normal concept, as opposed to, I guess I can just say right there, could I say, data frame 1 is filter, and then data frame 2 is data frame 1 dot filter this, and data frame 3 is, you could do all that. It's not going to hurt anything, but it's not a common practice. You might see, so basically the short answer is if you need to reference something, usually you need to do something with it at the very end. That would be a good answer. Or maybe if the chaining gets too ugly looking in your code, at some point you might want to say, hey, just separate the concern logically and let someone see. So you might actually have a couple data frames along this chaining. If there's 5, 6, 10, 20, 30 operations or transformations you're doing, you might simply have break kind of points, logical points, where you say this is the first bit and this is the second bit, and trust that the engine Trino is going to take all that queries that get generated based on all this looping and nesting and stuff, and be smart enough to go, hey, I don't have to loop it over and over and over. Okay. All right, hopefully that helps a little. What else we got there? Good. The SQL method. What can we do? We can run commands. We said that earlier. So there's a distinct on the ship mode. Same. Just showing that the API and the SQL do fit hand in hand, and ultimately, this and this end up being the same thing. We can go look at those two queries, and those, since the real simplicity of those will they'll still drive the same cost-based optimizer query plan. Absolutely. All right, here we go. We said, could we do a group by? And this time I turned it around. I actually showed you some SQL first. I said, hey, here's our good old-fashioned group by. So group by those ship modes that we saw up there, and just do a classic, by ship mode, give me the count, how many line items were represented. This is a generator, so the numbers actually come up pretty nice if you're wondering why they're so close together. How might that look like in the API? Well, I look a little bit lower, and I pretty much said, hey, let's do TLI. TLI was the tiny line items. That was the one that said, just go get it by the table name. And then I did a group by. Now, group bys actually return something a little different. It's a grouped data frame, so the functions aren't always exactly the same, what you can do, because it's a aggregated kind of rolled up thing. But we can do functions, easy functions, like we saw with the count up here. Those are first class functions there. So hey, take that, do a count. It knows what you're doing a count on in this situation. Count on the rows that are aligned by a specific ship mode. And then for sure, let's go ahead and do the sort like you see above there. Let's just see if that gets us the same results as above. Sure did. Air truck 8710, 8710, 8491 at the top. So yep, that looks good. So again, letting you look at SQL versus the data frame API specifically, doing the function calls, the transformation calls. And, of course, if you have some more thoughts on the group bys and aggregations, there are other ways to do the same thing. This is a side effect of, I always say when I learned PySpark, I would say, hey, there's always at least 2 ways to do everything. And I'm not talking usually about this. Yeah, there's 2 ways to do this, write the SQL or use the API. Very often there's 2 ways to write the API, 2 or more. So here's some examples, and I'll just run them while we're talking about them and kind of glance at these. These are doing the same thing. They're starting with the group by on the ship mode, and then instead of using the first class function of count, I pretty much said, hey, I want to do an aggregation, And then what's the argument of one of the aggregations? The aggregation itself. Do a column star, and then this is kind of the function name over there. What field, and then what's the count, and then I finished all that up with the sort, and there we go. You see another way. Hey, let's do a function. So it's not it's not a bad thing, but it's a thing to consider. There's often multiple ways. So sometimes you'll pick up someone else's code and go, "What's this?" And then when you look at it a little harder, you go, "Oh, I know how to do that. I just didn't know how to do it that particular way." All right, so there's we go. 3 different ways via the API, and then of course the 4th way of just writing the SQL statement to execute it. Fun. And of course, if you had the question, could I do a bunch of different aggregates against that group by? Sure. What are we doing here? We're just doing an aggregation. That .ag, we saw a method, and instead of supplying one of those functions, so it was within the parentheses, I just supplied n number of those. So there we go. Give me a count of the ship modes. We already saw that. Do a sum up the quantity, sum of the field called quantity, sure. And do an average of the field called extended price, sure. And then do a max. What's the max discount? Looks like about 10%. And this time, after all that, I did one more trick that I probably didn't show you here is how do you do descending instead of ascending? You say something like, hey, I don't want, the default is ascending is true. We just flip it around and say, nope, descending is false. So sort it by the field, count ship mode, and see that in reverse order. Did we show that earlier? I guess not. I'm looking back for a second. Sort. Oh, we sorted by ship mode. We didn't sort by the count. That probably would have been a way to see it a little earlier. All right, multiple aggregates. Multiple ways to do aggregates and multiple aggregates. Absolutely, all those things are true. And for giggles, because it helps sometimes, I'll let you see on screen that this element above and this element below are the same thing. They're going to get the same results. I would say the only thing different is if you're starting from scratch, from session up here where it says TLI, you would say session.table, pass it the argument of the table name, line item, and then put the dot group by. So I shorthanded it already there, but same, net, same answer, so on and so forth. All right, SQL versus the API, something to look at for a few moments. What are some other things to consider? Well, if you need to know some details, I mean by details a little bit, primarily for numerics, but this works for strings to a point, maybe not all the means and the max. There's a thing called describe. Now, describe is not the SQL describe. SQL describe is what we would call schema here, and that's the fields and the data types and so on and so forth. But describe actually says, hey, I'm going to go build some statistics across this entire data frame and show you what they might look like. So there we go. Kind of busy activity there. It's actually showing, if you kind of look carefully, it's actually saying for each column, order key, part key, supply key, it's building the results of that. It added one more field to the front called summary, which was what characteristic. And then the row is the numbers for that. So what I did to make it a little easier is I said, hey, what if we did take that same big line item, run the describe. In fact, I probably should have run the select first and then the describe, but we're expecting the engine to be smart here, and it doesn't matter which order. But it says build them, but only build them on 1, 2, 3, 4, 5, those columns. Build those statistics so we can kind of glance at them here in just a second. And we're actually crunching those, as you can tell, to come up with the answers, and there we go. So again, if there's more than 4 columns, there are, but I trimmed it down, there would just be another column, another column, another column. But this lets us see what we're trying to say here. For quantity, we read it kind of column down. This column name quantity is the field, the column, and then there are the values for these particular things. A max value of 50, a minimum of 1. There you go. It shouldn't be hard to expect. It's a generator. The mean is right down the middle, about 25. And so on and so on and so forth. There's our max discount we saw earlier, 10%, our min discount of 0, and a generator, put it right about the middle, right? About what would that be? 5%, I guess, is about what we're talking about. So good stuff here. It might help us. It might be useful to you in some kind of logic. If you're trying to figure things out, maybe this is just a tester to see how the logic is, the data quality is looking for. Does it fit in norms? And so on and so on and so forth. Now what I have here is actually, I think I'm going to run, it looks like I'm going to run two commands at once. I'm going to build one called string tests test 1 and string test 2. And they're really just saying, hey, could I, all this is from the data frame API, could I leverage some of the existing, or all of the existing Trino functions that are out there? Sure. I focused in on the Trino string functions. I didn't give you a link to Starburst Trino's string functions, but you can Google that and find it, and you're going to see a parody of what's listed there from SQL. Is also available there in the API itself. So we'll kind of look at it a little bit closer. So what we're doing here is we're saying, hey, let's, and I'm purposely kind of jazzing it up each example and show you there's multiple ways of doing things, right? Let's start with a session, run a SQL command that says, give me at least a couple columns. That's all it's doing. In fact, that is all. Select all from, select these 2 columns from that. No where clause or anything. And then on columns like ship details, I'm actually building or appending. We're saying, hey, on that data frame, build me a new data frame that has another column. I'll show you in a second what that looks like in SQL, but it's basically, hey, there's another column on the select list that's calling a function. And what is that function? It's the concatenate strings with the separator. So argument 1 is the separator. There's the literal of a greater than sign, space greater space. And then what do we want to concatenate together? The ship mode and the shipping instructions. And then I said, well, why don't I add one more column? Ship to details, lowercase. And what do I really want? I want the lowercase version. So it's the method, there's the function, lower ship details. So there we go. We should see this one is putting left and right together. Truck delivery in person, truck delivery in person. And then the other one was, okay, now that I have that field, build me another field. Now, what you might do is do something like this. If you really need to do 3 or 4 or 5 operations, could you nest them? Sure. Could you do them with adding a column, adding a column, adding a column, and then drop them all or just select them? Absolutely. You have options. And you have the right to expect, regardless of which option you do, not necessarily the Python code here, but when that code and that SQL that gets generated lands over there in Trino, you have the expectation, you have a rightful expectation to say, that cost-based optimizer in Trino is going to figure this out and do the least amount of work to solve the problem that I wanted. All right, so there was a couple examples really just to concatenate and lower, and I did a little bit more here, and in fact, there's a smarter way to do what I did here, but I just wanted to exercise a few functions. I said the same thing. I'll scroll up a little bit. Instead of going session SQL, I said session table. I referenced the table name, and then I could have, then I did a select. I really only want comment. So give me the whole table, but then give me another data frame with just comment. That's the equivalent of select comment from. And then I played that with column. Add me a new column. This one, unusual comment. Right there, named it. And then I used the function that returns a Boolean. Starts with. So I said, hey, does the comment column start with the word unusual? So we see some here that are unusual. And why? Because I think, in a second you're going to see I filter them all out. So when it's running, it could theoretically do them all. So look for things that are there, and if it has the word unusual it starts with, then put this new field's Boolean's value of true, otherwise it'll put it to false. And then I filtered out, I said, okay, now that I have this Boolean on this new data frame, filter out the ones that only have a true. That's why we have this and this. And then I did one more. I said, hey, adding another comment called comment modification. And I did the replace function. Hey, replace comment, the one I already had, with when I find the word replaces, find this, replace it with that. So I just replace unusual with uppercase weird. and then did a show on the end of that. Mainly what I was trying to make the point is the functions that exist in Trino are also available here as well. All right, let's kind of rush to the finish line and address the thing that we didn't. So when we think about SQL, I always think about the easy stuff. Projection and filtering, we've done that. Sorting, absolutely. Aggregations, absolutely, we've done that. And then, of course, we can't forget about our good friend, the join. So gave you a link to the join docs as well. But what do we have here? So I went in and started from scratch. I said, let's just go get from session the table orders and assign it to a thing called the orders data frame. Again, this is just a property, a variable name. Let's build another variable called line item data frame. And I started from the beginning. I didn't use one of the ones we had up there, mainly because all the previous ones threw away the things like the keys and stuff that I needed to join with. So I said, hey, give me that. And then you might notice, and I'll tell you in a minute why this is, but there's a new function here I introduced. I said, hey, rename order key as LI, line items, underbar, okay, order, line item order key. But nonetheless, first part would be, what is that? That is all it is. It's an as. Select order key as LI, underbar, okay. That's really all that's going to do at SQL time. But this is how we do it via the API. I'll go ahead and tell you, and you'll see it in the next line here, I actually use this. Well, let me just get into the join syntax, and then I'll explain it better. I said, build me a joined data frame. And what do I want to do? I want to take my larger one, my line item data frame. I want to join it. That's the transformation that I'm going to do. And what are my arguments? Well, my arguments are, what am I joining it on? Let's join it on the orders data frame. And then the next argument, and there's more, like inner, outer, all that fun stuff. But if you want to default, enter there, inner, join, you can just simply say, what's the on condition? What's the criteria? Well, I just simply said, hey, on the orders data frames order key, as long as it equals the line items order key. And this is kind of the reason I introduced a rename here. If we don't, and this data frame ends up having two fields, because it will put them together, two fields with the same name, it will, unlike PySpark, which just keeps them the exact same name, which itself is confusing, Trino is going to build two different names, and I want to control those field names a little bit more tightly. So I did a rename earlier. So I'm joining order key with order key, in all fairness. All right, so that's going to give me all, for everything that matches, all the fields in a line item and all the fields in order, because that's just how it works. And then if you want to remove some of those fields, so in other words, up in your select statement, if you actually only referenced a few columns, you would just kind of chain this with a select now. So, okay, from that joined data frame, now remove, only keep these values, select these, and then from those, I did a quick a sort on order key and line item. So let's see if that join can work. Join the orders and join the line items. Hopefully my cluster didn't shut down while I rambled forever there. There we go. There we go, order key, line item. And if you want to see this and more, what you do is you break this apart and walk into it slower and slower and slower. And what do I mean by that? I'll show you. Often people, well, I guess it won't be good to do it there. You could do this. You could say, hey, line item, join. So if you just want to see what happened with the join, I will put it right here. We'll just create a new node here, show. So say just do this with the show. Let's run that. Let that finish up. So do the join, but don't get rid of any of the columns. I want to make the point that this is usually what you do when you chain methods. You get something working, you chain the next method, you get it working, you change the next method and get it working. And then at some point you get rid of the things like the show. So if I was doing this interactively, I probably would have done this next. I would have said, hey, I'll try to figure out, hey, that's more fields than I want. It probably would have built that. I'll run it again. I'll show you, oops, syntax, two dots, there we go. We don't want that. I probably am missing one at the end, yep. Dot show there. All right, so run the join, then run the select, and then run the show. So there we go. And then you want to tap on probably something like this sort, and so on and so on and so forth. And this is the benefit here of using the benefit of using, let's see if we can delete that one before I forget. All outputs, delete, run, edit. Delete that cell. So I don't want to mess up my version control here. This is the benefit of doing this as opposed to doing it from maybe a command line or running a little Python program over and over. You get easy ways to quickly try things. Often in practice, you'll end up taking a lot of this code and move it into your data engineering pipeline code and automate that stuff, put it in production, so on and so forth. So it's just the power of notebooks in general. A little bit of a sidebar there. All right, so we did a simple join, no big deal. If it was other types of activities, we can look here and just make sure you agree that we have all the join types you're looking for. So I'm going to add me a new column here, a new tab, and we'll go to the join page. And there we go. Here's what we support. Enter, join, that's the default. So I left that off. If you wanted to add another one, I was going to see if we had a good example. Nobody did anything more than a simple one. Yep. You're just going to supply after that second argument. So joining takes, there you go, right. Parameters, the thing I'm joining, the on, the how. I just need to supply, that word. I would say comma and then just say right or right out or whatever's appropriate. Very easy to kind of get those in there. But there go cross joins, left anti-joins, semi-joins, all that fun stuff is supported. I kept it pretty simple with an inner join. And if we have a little fun with it, could we join more than more than two tables? Absolutely. But in a reality, we get to start programmatically showing what really happens. Engines, these big data engines, these MPPs like Trino and others, they really join two things at a time, and the results of something, and they join that, and they join that. So if you look here, there's a lot of code here, but if you look a little closer, it's not a lot of code. It simply says, hey, from the joined data frame above, it's already joined two things. Why don't I just keep a few values? So I kept the line items and the line status. And then I also renamed the customer key. And this is where you kind of, I actually should have put this in the other way. I should have renamed that first and then did the drop, but it works. The power of the API, cool. I played the game with the keys because I don't want to have a collision that might be confusing to me later. I changed the name of that customer key here, and then I only grabbed certain order keys. So there we go. I have a smaller orders, line items, joined result there. I grabbed the customer table that's out there. And this one I used the SQL command. I said, hey, go get it. Select it from customer, just the fields I need. I went ahead and renamed it using that pattern I was using of, customer and nation key. It has a key called nation key, US, Canada, so on. I went ahead and joined those together, the smaller orders with the join. Joined it on the, customer key, pretty easy stuff. And this is, I'm showing the results all at once. You would do this, feel by line by line, work it. And then when you're all done, go, yeah, that's what I'm looking for, and ship it, kind of a model. Use the power of the notebook, not simply just read all this code here. You didn't just type it all and run it. You typed a line at a time and made sure it worked. I went ahead and grabbed the nation field. This is the thing that has a nation key and then a nation name, a nice name like United States instead of a number. I went ahead and used the table method instead of the SQL method, again, to refresh that, remind you that there's multiple ways of doing just about everything. Dropped a few comments. Earlier I showed you can drop them with one command, drop, region name, comma, comment. I went ahead and showed, sure, could you do it in two passes? Sure. You got a lot of approaches here, a lot of ideas here of how to tackle it. And then lastly, I finished up. I did the last join. Hey, let's join, the result of the three tables with the nation field here, using that nation key, and then I did all my cleanup. Again, I built this, practiced this, line by line, and made sure it resulted to what I want, but I'm basically just saying, hey, clean it up, that nice name, give me a pretty name like nation name, only keep the nation name and the average price. I guess I didn't mention that's what we were trying to do. We were trying to determine the average line item price by the pretty nation name, not just a code. All right, so there we go. Did a group by on the nation names with the group by, did an average on the field extended price, okay. That gave a name, average extended parentheses extended price. I renamed it. So I said, hey, with column. In fact, instead of a rename, I did a function. I added a new one. I said, hey, call it average price. Do the function rounding, to 2 decimals. And then I said, hey, at that point we had 3. And I said, hey, I really only want 2 of them. I could have done a drop. I said, just give me nation name and average price. Sort it by the average price in descending order and show it. This was kind of like the kind of end cap. I think this is probably the last big data frame bit of code I'm going to run here. You have access to this. Take this, break it apart, either clone it, copy it to another one below here, or just type it up, mess it up as you go. It's okay. That's the best way to kind of see that. And I'd be glad to work with someone or help you with the questions. Lastly, okay, you might not like this. I like this. You might not like it. You can still write a Python data frame code and do something like this as well. So this is the functional equivalent, one way at least, to do the same information I did up here. And for a lot of us, this might make more sense, select basically, I can see I'm doing some joins from line item to orders, orders to customers, customers to nation. Oh, okay, I see that I only want certain order keys on the O, which is, the orders field. Sure. I see that I'm doing group by on that name. Sure. And then what do I want? I want basically, there's all that nesting, right? Average the line item price and round it and rename it as average price and then do an order by. So functionally the same. I didn't do I did do the except to show you that this data frame and that data frame, regardless of which way you attacked it, ended up being the same work. And then the bonus, if you're running these yourself, is to keep going back to the query history in Trino and make sure that maybe not the SQL that comes in. The SQL that comes in for this will look exactly like this. The SQL that comes in for this will look a little bit more exhaustive than this, but something to consider. But the results and the query plan themselves will be the same. So I would say, hopefully this will give you just a taste that, again, if you came from PyStarburst or one of the other Py data frame kind of things, okay, cool, we can still do that in Starburst. And if it's net need to, you're just writing a SQL today, and this is like a kind of a primer. The takeaway I would take for that audience is I absolutely could build my analytics stuff. We did this kind of just trying a lot of things, but primarily my transformation job, like take this data, clean it, enrich it, and rebuild it, reload it somewhere else into maybe like a structure zone from a drop zone or something like that, a raw to structured kind of an approach as well. So hopefully these examples get you a good start, and I hope you had a good time.